Okay, this is the P2 paper from January 2021. It's question number 3, and as we can see, this is an exponentials and logs question. We're going to be using the laws of logarithms. We're going to be solving equations using logs. Let's have a look at part 1. Now, there's actually 2 separate ways that we could have approached solving this equation. I'll explain to you why I'm going to use the method that I use. What we could have done would have been to take log of both sides. So we could have done log and log. And then we could have brought the x plus 2 down using the power law, rearranged it all and got x equals. But simply because they've got that they want the answer in that format, I'm not going to choose to do that method. I'm actually going to say, right, no. If we start off with this, another way that we can approach it is to use the idea that if I have the power statement a to the x equals b, I should be able to change that into a log statement. And the log statement would be that the base remains the same, the base of the exponent and the base of the logarithm. I know a logarithm is a power, so that means that part goes there, so I get that statement. You could just learn the fact that these two are interchangeable, but that's the way I try and remind myself when I've not looked at it relatively recently. So I'm going to use that idea here then, that if I've got 7 to the x plus 2 equals 3, then I would say log, the base is the same as the base, a logarithm is a power, so I end up with that as my answer. So log to the 7/3 is equal to x plus 2, which means x is log to the base 7/3 minus 2. Now they've said they want it in the form log 7a. So what I need to do is I now need to work out what 2 is as a log statement, okay? So 2 is the power that 7 has to be raised to give me 49. I know that 7 squared is 49. So from that, using exactly the same idea again, the base is the same as the base, the logarithm is the power, so I end up that 2 is equal to log base 7, 49. So this is really testing that you fully know the range of skills within the logs and exponentials chapter. So I end up just interchanging that for that, and then using another of my log rules. Log a minus log b is log a over b. So this is going to be log to the base 7 of 3 over 49. So that's quite a testing one there, that we needed to know all our different skills. And you can't favour one over the other in terms of methods, because sometimes they'll push you in one direction, which they have done with this one. Okay, part 2. Part 2 says, what have we got? Completely different question. Using the laws of logarithms, can we solve this equation where I've got a log to the base 2y, log to the base 2, log to the base 2, and I've got that 1 there. So again, a couple of different ways of doing this. I'm just going to go with a method that I would use here. We've got 1 plus log 2y, excuse me, plus log 2y plus 4 equals log 2 5 minus y. Now what you could do, I'm not going to do this, but what you could do is get everything over to that side and leave the 1 there, and then get a statement just for log 2, and then use this skill again. I'm actually going to do it slightly differently and say that what I'm actually going to do is change 1 into logs, because I know that 1 is log 2, 2. 1 is log a, whatever the value is. It can be log 3, 3, log 5, 5. So because I know that, that means that I've now got all of my terms are going to be log to the base 2's. So I will still get to the same end result of having an equation, probably a quadratic, I'd imagine, at this stage. But I'm going to do it using this method rather than the previous method that I just said. So use all our log rules. We want to combine all these things. So on the on the left-hand side here, I've got log A, log B, log C. I can just log A, B, C. I can just combine all those in one go. So I've got log to the base 2 of 2 times y plus 4 is equal to log to the base 2 of 5 minus y. So that's why I chose this method, was because straight away now I can say that this bit, oops, sorry, that highlighter. Why is my highlighter so small? Let's make it bigger. That this bit is equal to this bit. Okay, log of something is equal to log of something, then those two bits are the same as each other. So if I'm looking at that, I get that 2 to the y plus 4 equals 5 minus y, and I've still got a little bit more work to do, but it's going to be a quadratic. Well, let's just multiply it all out and tidy it up. We'll do it. So I was going to try and do two things at once there. So 2y squared plus 8y equals 5 minus y. Rearrange all that, make it equal to 0. So that's 2y squared plus 9y minus 5 equals 0. And I was sort of jumping ahead to this stage. I'm assuming it's going to factorise, okay? It doesn't have to. You can go through the use quadratic formula, but I'd certainly have a go at factorising first of all. If you're struggling with how to factorise one of these quadratics where that number is bigger than 1, then go and have a look on my channel elsewhere where I show you how to do that, how to solve or how to factorise quadratics. So doing that is going to give me 2y minus 1 equals 0. Let's do it down here. Or y plus 5 equals 0, which is going to give me y equals a half, or y equals minus 5. And it's almost a natural instinct in me now to go back and say, have I answered the question? Are there any things I need to be careful of? And certainly this type of question there are. You can't have the log of a negative, so I can't have the minus 5 in there. So not a valid solution. And the examiners are looking to take a mark off you if you don't say that. So the actual answer is only y equals a half. Other thing to just check, did they just want the y values? Is it coordinates where you want all of it? But no, I finished the question there by doing that one. So a really important question for you to be able to do and to be able to learn from moving forward. Hope that all makes sense.